The Higgs boson, also known as the God particle, has been the subject of much scientific debate and speculation in recent years. But what exactly is it? And could it really destroy the universe as some have feared? Let's start with the basics. The Higgs boson is a subatomic particle that was first theorized by physicist Peter Higgs in the 1960s. It is believed to be responsible for giving other particles mass, which is why it's sometimes referred to as the mass-giving particle. But why all the fuss? Well, for one thing, the Higgs boson is incredibly difficult to detect. In fact, it wasn't until 2012 that scientists were able to confirm its existence using the Large Hadron Collider, LHC, a massive particle accelerator located in Switzerland. The discovery of the Higgs boson was a major breakthrough in particle physics, and it earned Peter Higgs and his colleague Francois Englert the Nobel Prize in Physics in 2013. But it also raised some concerns among the general public. Some people feared that the Higgs boson could be dangerous, and that its discovery could lead to the destruction of the universe. But is there any truth to these claims? Have you ever wondered how particles get their mass, or how the universe came to be? These questions have puzzled scientists for centuries, but thanks to the discovery of the Higgs boson and the development of the Higgs mechanism, we're starting to unravel some of the mysteries of the subatomic world. To understand the Higgs mechanism, we first need to understand quantum fields. In quantum mechanics, particles are not seen as tiny solid objects, but rather as waves or vibrations in a field. These fields pervade the entire universe and are responsible for the behavior of particles. The Higgs mechanism is a theory that explains how particles get their mass. According to this theory, particles interact with a field known as the Higgs field, which gives them mass. The Higgs field is thought to be present throughout the universe, and particles that interact with it are slowed down, giving them mass. But how does this work in practice? Imagine a crowded room filled with people. As they move around, they interact with each other, slowing each other down and making it more difficult to move through the room. In a similar way, particles that interact with the Higgs field are slowed down, giving them mass. But there's still much we don't know about the Higgs boson and its role in the universe. As physicist John Ellis explains, we know that there's a Higgs boson, but we don't know what it's made of or how it interacts with other particles. Despite the many unanswered questions about the Higgs boson and quantum fields, scientists are continuing to study these phenomena in order to better understand the nature of particles and the universe. One area of research is the study of dark matter and dark energy, which make up a significant portion of the universe but are still poorly understood. By studying these phenomena, scientists hope to gain a better understanding of the universe as a whole. Another area of research is the development of new particle accelerators, which could help us study particles at even higher energies and with greater precision. False vacuum and the metastability of the Higgs field. The universe is a vast and mysterious place, full of wonders and dangers that we are only beginning to understand. One of the most intriguing phenomena in the world of particle physics is the concept of the false vacuum and the metastability of the Higgs field. We'll explore what these concepts mean and whether they could pose a threat to the universe as we know it. In quantum mechanics, a vacuum is not an empty space, but rather a state of minimum energy. The Higgs field is thought to be in a vacuum state, which gives particles mass. However, there is a possibility that this vacuum state may not be the true minimum energy state, but rather a false vacuum. In a false vacuum, particles are still able to exist, but they may be unstable and prone to decay. The Higgs field is thought to be in a metastable state, which means that it is stable for now, but could potentially decay into a lower energy state in the future. This could happen if the Higgs field were to be disturbed by a high-energy particle collision or other event. If the Higgs field were to decay into a lower energy state, it could have catastrophic consequences for the universe. The decay of the Higgs field would cause a phase transition, which would release a massive amount of energy. This energy could create a bubble of true vacuum that would expand at the speed of light, destroying everything in its path. While the idea of a false vacuum and the metastability of the Higgs field may sound alarming, most scientists believe that the universe is not in immediate danger. According to theoretical physicist Lawrence Krauss, the universe is probably not in a false vacuum state. And even if it were, it would take an incredibly long time for it to decay. However, there are still many unanswered questions about the nature of the Higgs field and its potential instability. As physicist Sean Carroll explains, we don't know for sure whether the Higgs field is in a true or false vacuum state, and we don't know when or if it will decay. What is vacuum decay? In particle physics, a vacuum is not an empty space, but rather a state of minimum energy. However, there is a possibility that this vacuum state may not be the true minimum energy state, but rather a false vacuum. In a false vacuum, particles are still able to exist, but they may be unstable and prone to decay. Vacuum decay occurs when a false vacuum state decays into a lower energy state. This can happen if the false vacuum is disturbed by a high-energy particle collision or other event. When this happens, a bubble of true vacuum is created, which expands at the speed of light and destroys everything in its path. The idea of vacuum decay may sound like science fiction, but it is based on real scientific principles. According to theoretical physicist Lawrence Krauss, vacuum decay is a real possibility based on our current understanding of particle physics. While the chances of vacuum decay happening in our lifetime are extremely low, there are still many unanswered questions about the nature of the universe and the stability of its vacuum state. As physicist Sean Carroll explains, we don't know for sure whether the universe is in a true or false vacuum state, and we don't know when or if it will decay. If vacuum decay were to occur, it would be catastrophic for the universe. The expanding bubble of true vacuum would destroy everything in its path, including stars, planets, and even galaxies. The destruction would be complete and irreversible, leaving nothing behind but a vast expanse of empty space. Is the end near? While the idea of vacuum decay may sound alarming, most scientists believe that the universe is not in immediate danger. According to astrophysicist Katie Mack, the chances of vacuum decay happening in our lifetime are incredibly low, and even if it did happen, it would take billions of years for the bubble to reach us. However, there are still many unanswered questions about the nature of the universe and the stability of its vacuum state. As physicist Brian Cox explains, we need to continue studying the universe and its fundamental properties to better understand the risks and potential outcomes of vacuum decay. That being said, there are still some unanswered questions about the Higgs boson and its role in the universe. For example, some scientists believe that there may be multiple Higgs bosons, each with different properties and effects on other particles. There are also ongoing experiments to study the behavior of the Higgs boson in more detail. These experiments could help us better understand the nature of mass and how particles interact with each other. The thought of the Earth suddenly being swept away at any moment and without warning is no doubt a frightening one, and current measurements of the Higgs boson and top quark masses certainly seem to imply that this is not yet a possibility that can be completely ruled out. But taking into account the uncertainties in our current measurements, as well as the fact that the universe is still here despite the high-energy environment of the early universe, it cannot yet be conclusively decided whether or not vacuum decay is inevitable for the universe. What's more, if we truly are living in a metastable vacuum that is ultimately fated to decay, the incredibly long possible lifetime of this metastable vacuum, as well as the sheer scale of the universe, means that vacuum decay is likely no more of an existential threat to humanity than the eventual expansion of the sun. Even if humanity was unfortunate enough to find itself in the path of a bubble of true vacuum, perhaps one could find comfort in the fact that the expansion of the universe will likely prevent vacuum decay from ever reaching the entirety of the universe, and that elsewhere in distant galaxies, life may continue. If you enjoyed the video, please give it a thumbs up and don't forget to subscribe to the channel. And it would be great if you could share your thoughts in the comments.